Hello everyone. Today we will discuss about the Virial Theorem. This is very important. In Virial Theorem, first of all, this gives we all know that this gives time average of various mechanical systems. Now, as we know that the expectation of the total energy, that is equal to expectation of kinetic energy plus expectation of potential energy. We all know this thing. Now let let us consider a system of n particles. For that case, if we want to find out the net force on the particle, the force will be Fi, because we are considering a system of particles, and here in a system of particles I am taking about the ith particle. Okay, so on the ith particle the external force will be, that is, dpi dt, that is, or otherwise you can say pi dot, right? Now we define this r, the vdl, as g equals to sum over I pi dot ri. Now if we take the time derivative, then I will get sum over I pi dot ri plus pi dot ri dot. Now we know that this ri dot is the velocity. So from here I can write that, considering the total mass of the system be m, then I can write that this is equal to, for the second term, for this term I can write that this is sum over I mi, not I am taking about the whole system. So m vi dot vi, I can write it, plus sum over I pi dot ri, I can write it. So ultimately from here I can conclude that this is equal to half sum over I times 2. If I do half times 2 and we take this half inside this summation, so if I write it something like this, 2 times half m vi dot vi plus sum over I pi dot ri, I can write it like this. So ultimately I can write that 2, this is what, sum over I half m v square plus sum over I pi dot ri. So this will be 2 times kinetic energy plus sum over I pi dot ri. I can write it like this. Now we need to find out the time average. So what is the time average of dg dt? This will be, if we consider the time, the total time period, that is tau, then dg dt will be 1 upon tau integration 0 to tau dg dt times dt. So I will get 1 upon tau g of tau minus g of 0. That much I can write from here. Now if I can write from here that much, and this is equal to what? This term will be equal to 2t plus sum over I pi dot ri. I can write it like this. Now if we consider a periodic function, so for that case, if we consider a periodic function like this, suppose this is the total period. So the nature at the beginning point, suppose at time t equals to 0, and the nature at the ending point at t equal to tau, that will be same. So I can clearly write, if the function is periodic, then I can write what? G of tau minus g of 0, that will be equal to 0. And if the function g is non-periodic, then at time t tends to infinite, then it will come back to the same property which was at initial time. So I can write that at time t equals to infinite, for a non-periodic function, g of tau, that is equal to g of 0. So for both the cases, we can write what? We can write that g of tau minus g of 0 for periodic or non-periodic case, this is equal to 0. So I can clearly write what? 0, that is equal to 2t plus sum over I pi dot ri. I can write it. Now if we take the total time average, we have already taken the time average, so I can clearly write that 2 time average t, that is equal to minus sum over I pi dot ri. I can write it like this. So this time average t, that is minus of half sum over I pi dot ri. This will be the thing. Now suppose you have the potential as a given function. So we know that if potential is v, suppose that the potential energy is given as v. So here v is the potential energy, and we know that what is the force? The force is minus grad v. So since it is a one dimensional thing and we are dealing with only the space coordinate and one direction, that so I can write that this is minus dv dr or del v del r. So from here I can write that expectation of t, that is equal to minus half sum over I minus of del v del r dot ri. I can write it clearly because we know that the rate of change of momentum, that is force. So pi dot is fi, and instead of fi I can write that this thing I can write. So this is minus half sum over I ri dot del v del r, and the minus will become plus. Okay, so this is the expression of kinetic energy. Now I guess you won't get understand what is happening here. So for that case, take that the potential function v, suppose this is k r to the power n, or rather if you can say, I am changing this constant here, I am writing that c r to the power n. So what I will get? I will get del v del r, that is equal to n c r to the power n minus 1. Now del v del r dot r, this will give me what? N c r to the power n minus 1 dot r. So this is n c r to the power n. So this is n v. So from here, putting this value in this equation, which is this one, average t, that is equal to this. If I put this value, if I put this value in the above equation, then I will get that average of t, that is equal to n by 2 average of v, and that is the relation between t and the kinetic energy and potential energy. So from here I can clearly write that the total, we know that that expression of the total energy, that is expectation of kinetic energy plus expectation of potential energy. So if I want to find the ratio of the total energy and the kinetic energy, or the total energy and the potential energy, I will find it out easily. So if we take that, if we want to find the ratio of total energy and the potential energy, then what I will get, I will get here, since we have seen that we have this equation ultimately, T equals to n by 2 V. So I can write that E, that is equal to n by 2 V plus expectation of V. So this will be n by 2 plus 1 expectation of V. So expectation of E upon expectation of V, this is n plus 1 by 2, sorry, n plus 2 by 2. I can write it like this. And after that, if we want to check the ratio of kinetic energy and the total energy, so what I can write? So since I have this equation, this capital T, expectation of the time average of kinetic energy, that is equal to n plus half potential energy. So I can clearly write that this thing, that we can write that V, that is equal to 2 by n T. So putting this in this equation, that the total energy is kinetic energy plus potential energy, I can clearly write that the total energy E, that is kinetic energy T, and the potential energy V, and V can be written like this. So I can write that expectation of E by expectation of T, that is n plus 2 divided by n. And here I got what? That n plus 2 divided by 2. So now let's take a problem. Suppose you are given that this that's all for the theory part. Now if you want to deal with a problem, that will be easier for us. So the problem that, consider a system of n particles which are weakly interacted at any sufficient high amount of temperature, which is suppose T, then, and also suppose the restoring force restoring force acting is proportional to x to the power 5. Now find the total energy and heat capacity. So how to find it out? As we know that this T, the total, it is given that the restoring force, that is restoring forces, we have already seen that the we can represent the second term which was in the Virial coefficient, well, I mean this term, this one. I just want to represent this term because Pi dot is the force. So here I can write that T, that is equal to n by 2 V. That's what we know. Now what is V? V means F dot R. So F means del V del X dot X. So the potential energy that will be proportional to x to the power 5. This is the force. Del V del X was the force. X to the power 5 dot X. So I can clearly write that this potential energy, this average of V, that is proportional to x to the power 6. So here, as we are showing that expectation of T, that is equal to n by 2 expectation of V. So what is n here? N equals to what? 6. So I can clearly write that expectation of T, that is equal to 6 by 2 expectation of V, that is 3 expectation of V. Now they have asked me for the total energy. So we know that this total energy, that is equal to T plus V. And now we also know that this average kinetic energy, that is half kBT, right? So what will be the value of average potential energy? That will be 1 by 6 kBT. So I can clearly write from here that half kBT plus 1 by 6 kBT. So this will give me 4 kBT by 6, that is 2 by 3 kBT. Now for this is for a single particle case. Now for n number of particle case, what I will do, I will just multiply a n with this. So expectation of E, that will be 2/3 n kBT. That is the total energy of the system. And now the specific heat C, that is del average E del T. So this will be 2 by 3 nkb. And that's all for this class. Thank you, everyone.